Hello everyone, I am Reggie Dawson. Welcome to the React Fundamentals course. This course was created using the displayed version of React Native. This slide shows the version of React Native for which the information in this course applies. In this module, we will get started with React Native. We will begin by setting up the tools and software we will need. First, we will look at the reasons to choose React Native. After that, we will set up a text editor. Then we will set up a development environment for React Native. Once that is complete, we can create the actual app. After the app is created, we will take a look at how the project is structured. Finally, after we demo the app, we will take a look at a few ways we can debug React Native apps. After this module is finished, you should know enough to get started building apps with React Native. There are now multiple frameworks that allow JavaScript developers to build mobile apps. The choice of the best framework is subjective, but my first choice for a project would be React Native. React Native is based on the React framework. If you are watching this course, chances are you are familiar with the framework that powers sites such as Facebook and Netflix. React, which is created by Facebook, allows you to build apps using components. I've used many of the popular app frameworks, and in my opinion, React is the easiest to learn. This is because, unlike other frameworks, React uses standard JavaScript syntax. A component in React is just a JavaScript function or class. In vanilla React, you will be building apps with components that you compose yourself. React Native includes many of the core components you will need in order to build your apps. The interesting thing about these components is that they translate directly to a native counterpart on the respective device. The view component, for example, translates to a view group on Android and a UI view on iOS. Some JavaScript mobile platforms use a web view to host the app. React Native apps, on the other hand, are hosted in the native view. As a result, React Native apps will perform as well as a native app written in Java or Swift. React Native also provides access to Expo. Expo provides a suite of services and features that make React Native development even easier. The Expo application services allow you to build an app in the cloud. This allows you to build an app without having the respective development kit installed on your local machine. This means you can build an iOS app without a Mac. We will not be using Expo in this course, and instead we will use the React Native command line interface to build the project. Now that you understand why you would want to choose React Native, in the next clip we will configure a text editor to build our project with. The choice of a text editor also comes down to personal preference. The text editor is where you can create and manage the files that will make up your app. The other advantage of using a text editor are the extensions that are provided. These extensions can verify the syntax of your code. This will highlight any code that will produce an error. These extensions will also provide snippets from frameworks such as React. This allows you to scaffold a component with the keyboard shortcut, for example. Extensions also provide utility functions, such as creating a new project. Brackets is a powerful open-source text editor built by Adobe. The editor is built in JavaScript and provides a lot of powerful extensions. I've used Brackets in the past, but my current preferred editor is Microsoft VS Code. If you go to code.visualstudio.com, you can download the editor. Install VS Code and then launch it. If you don't have a project loaded, the welcome page will be displayed. Click the extensions icon. At the bottom of this window will be the extensions that are recommended to be installed. If you type React in the search bar, you can see the extensions that are available to install. The first one is the ES7 React Redux React Native Snippets. This provides snippets for React and React Native, as well as Redux. Redux is a state manager that you can use with your React apps. The documentation for this extension shows all the snippets you can use. The React Native Tools extension does not provide any snippets. Instead, it lets you debug your app and run React Native commands from VS Code. With this extension, you can launch the app on an emulator or Android device directly from VS Code. Although these extensions are useful, I will not install any of them. Check them out for yourself and see if any of the functionality provided will be helpful. If you remove React from the search bar, you will see the installed extensions. If it is not already installed, I would suggest that you install ESLint from Microsoft. ESLint will analyze your code and highlight any problems. ESLint even analyzes JSX, which is what we will use to define the views inside React components. Once you have your editor configured, we are ready to set up our development environment, which we will do in the next clip. React Native allows you to create apps for iOS and Android from the same codebase. Since we are not using Expo, we can only build an app for iOS if we have a Mac. To build an app locally for iOS or Android, we will first need to install the appropriate development kit. For iOS, that means you need to install Node and Watchman first. This can be accomplished with the Homebrew Package Manager. You will also need to make sure a proper version of Ruby is installed. This is installed by default in Mac OS, but may need to be updated. Ruby is needed to install CocoaPods. And then the last thing you will need to install for iOS is Xcode. This only runs on the Mac OS. In addition to compiling the iOS app, Xcode is also where you will configure the simulator that you can use to test your apps. The development kit for Android can be installed on a Mac or Windows PC. You will also need Node for this install. This can be installed from nodejs.org. You will also need to install the Java Development Kit. The React Native team suggests that you install version 11 to avoid any issues. I have version 17 installed and the current version is 19. There is a small issue with Gradle that we may need to fix, but feel free to install version 11 at the URL that is displayed. Or, if you want to install version 19 of the Java Development Kit, you can download it at this URL. As an alternative, you can use the Chocolatey Package Manager for Windows to install Node in the Java Development Kit. Once you have Chocolatey installed, you can use these commands to install the LTS version of Node and the latest version of the Java Development Kit. The last thing we need to install is Android Studio. This is needed to compile an Android app and includes the emulators that we can use to test the app. You can download Android Studio from the URL that is displayed. When installing Android Studio, make sure you select these options: Android SDK, Android SDK Platform, Android Virtual Device, and Hyper-V. If you happen to miss any important installs, we can add them later. Once Android Studio is installed, open it up. If you missed any options that you need, they can be installed now. Click on More Actions and choose SDK Manager. Here's where we can add and remove any packages that we need. First and foremost, the most current version of Android may have been installed. If not, make sure you select it. Now, even though we have the most current version of Android, the React Native documentation states that it needs Android 12s. Scroll down and expand the list under Android 12. Make sure Android SDK Platform 31 is selected. You will also need to choose one of the Google system images. Then in the SDK Tools tab, make sure Android SDK Build Tools is selected. Click Show Package Details at the bottom and make sure version 31.00 is selected. Also make sure Android SDK Command Line Tools and Android Emulator are installed. If you have an Intel processor, the Intel x86 Emulator Accelerator Haxum installer should be selected. If you use AMD, then the Android Emulator Hypervisor driver for AMD processors should be selected. Also make sure the Android SDK Platform tools are installed. Click Apply to install all the packages that you need. After it's finished installing, make sure you copy the SDK location. We will need this for the next step. On a Windows PC, click on the search bar and type in env. When the suggestions come up, choose Edit the System Environment Variables. In the System Properties box, click on Environment Variables. In the System Variables pane, select New. The variable name will be Android_home. The value of the variable will be the SDK location that we copied from Android Studio. Click OK to add the variable. After that, select the path variable and click Edit. Click New here to add the path to the Platform Tools. This is the Android SDK location with the Platform Tools folder appended to the end. We add this so the Platform Tools are available from the command line. The last thing we need to do is go back to Android Studio. Choose More Actions and select Virtual Device Manager. This is where you configure your emulators. Click Create Device. Make sure you are in the phone category and choose Pixel 2. Then click Next. Here we choose a system image. We will choose the most current version, even though we also installed Android 31. We can also install system images directly from this window. Click Next. Then in this final window, we can give our virtual device a name. If we click on Show Advanced Settings, we can configure other options such as networking or camera emulation. Click Finish. After the emulator is configured, click the arrow to the right to launch it. This emulator behaves the same as an Android device connected to your computer through USB. Now that we have the development environment set up, in the next clip we will create the project. In this course, we're going to be building an app for the Global Mantics Corporation. This is a training company that is looking to expand their business with a mobile app. In addition to information about the company, there will be videos explaining the services Global Mantics provides. Blog posts from the Global Mantics site will also be mirrored in the app. There will even be quizzes prospective students can take to determine what courses would be the best fit. In the last clip, you should have installed Node.js as part of setting up the development environment. Node.js includes the npm package manager, which we typically would use to install React Native. We will use npm first, but just to make sure that no old versions of React Native are installed. In a terminal window, run this command. This will uninstall either of these packages if they are installed globally. Once you do that, navigate to the location where you want to create your project. In order to create the project, we will use the init command. npx allows you to run commands and use packages even when they are not installed on your local machine. In this case, we are using the React Native init command, which creates a new project. The name of the project will be Global Mantics. We can also pass some options to this command. With the template option, we can select the template to base the project on. This can be an npm package, a local directory, a tarball created by npm pack, or a link to a GitHub repository. We can also specify a custom directory to use for the project. By default, a directory with the project name will be created to contain the project. With this option, we can override the default behavior. The version option allows you to choose a specific version of React Native. And the title option will let you use a custom app title instead of the name of the project. The skip install option will skip installing any dependencies, and the npm option will force the use of npm. We won't add any options, so hit the enter key to create the project. You will be informed that React Native needs to be installed. Enter Y to proceed. Once you do that, the default template will be downloaded and any dependencies are installed. A folder named Global Mantics will be created that contains your project files. Now that the project is created, in the next clip, we will take a look at the files that were generated. In this clip, we will take a brief look at the files that were generated with the project. Navigate to your project folder in your text editor and open it. The first file we will take a look at is the package.json file. This file contains information about your project's configuration. The scripts are configured to run using the npm run command. The Android and iOS scripts will launch the app on the respective platform. This command will also make use of an emulator or simulator. The start script will launch a server that communicates with connected devices. The test script will run any tests that are configured. By default, the app component is configured with a basic test. And finally, the lint script will use the ESLint tool to analyze the code for any problems. The dependencies list any packages that are required, and the dev dependencies list any packages that are required only in development. The next file we will look at is index.js. This is technically the first page that loads in our app, but all it does is load the root app component. First, it imports app registry, which we use to register the root component. Then we import the app component, followed by the name, which we import from the app.json file. App registry is used to register the component using the app name, and the app component is passed to this method. If we take a look at the app.json file, we can see where we got the name that we used to register the app. Then finally, we will take a look at the app.js file, which is the first component that is displayed when the app starts. All the pages we add to the project will start with the imports. Here, the first thing we import is React. The node import is for flow and not needed. We can remove it now if we like, but we will take care of that later. We will eventually be removing most of this code. Then we have the imports for the various React Native components this file uses. Then after that, we have some imports for components that have been created for a generic new app screen. After the imports, we have the component that is displayed when the app starts. We won't go any further as we will learn to build our own components very soon. Now that we have looked at some of the files in the project, In the next clip, we will launch the app and take a look at what we have created. In this clip, we will launch the app we created using the emulator. The first thing we need to do is launch the emulator. Open up Android Studio, and from the menu, choose Virtual Device Manager. The right arrow icon under Actions will let you start the emulator. The pencil icon will let you edit the virtual device. The downward arrow provides some commands that allow you to manage your emulator. Launch the emulator by clicking the arrow. Once the emulator is up and running, navigate to your project folder in the terminal. First, we need to start the Metro bundler. This is similar to Webpack and will bundle the JavaScript files into a single file. Then you need to open up a second terminal window. This will allow Metro to continue running. Navigate to your project folder and use the Run Android command. The Run Android command will launch the app on the emulator. After a minute or two, the app should compile and launch. When the app launches, some information about the app will be displayed. First, it explains that any changes will be reflected without reloading the app. Go to the app.js file in your text editor. In the first section, change the word edit to update. When you save the project, your app will automatically update. If you press Ctrl and M, you can bring up the Dev menu. Then finally, if you scroll down, you can see information on how to build apps with React Native. Now that you understand how to launch your app on the emulator, in the next clip, we will take a look at some options for debugging the app. In the last clip, I mentioned the Dev menu that we can open up in the emulator. In this clip, we will take a look at that menu and go over some of the options that are available. Make sure to follow the steps to launch the emulator from Android Studio. Once that is running, you can launch the app on the emulator. After the app is up and running, you can hit Ctrl M to launch the Dev menu. The first option in the menu is Reload, which will just reload the app to reflect changes. You will rarely need to do this as changes are normally reflected once the project is saved. You can also reload the project from the Metro Bundler terminal window by pressing R. Change bundle location lets you change the IP address where the app bundle is located. To ensure the emulator works correctly, I recommend you do not change this. The next option in the menu is Show Element Inspector. This will let you inspect the various elements on the page. If we click on the Step 1 heading, we can see some information about this element. If you go back to the Dev menu, we can hide the inspector. The reason any changes are reflected almost immediately is because of fast refresh. If for some reason you want to turn it off, you can do that from the Dev menu. If you select Performance Monitor, you will be taken to a screen and be given permission to display over an app. Choose the Global Mantics app and go back. Once you do that, the Performance Monitor will be displayed. This will give you real-time feedback on how your app is performing. The Performance Monitor can also be hidden from the menu. The Settings menu has a few options relating to the performance and debugging of the app. The Enable Sampling Profiler option is for visualizing your app's JavaScript performance using Hermes. Hermes is an open-source JavaScript engine that works with React Native. If you choose the Debug option, you'll be able to use Chrome Developer Tools to debug your app. React Native also uses a log box to display any errors or warnings in the emulator. We can see this in action if we go to the app.js file in our project. If we add a console error message to our component and then save the project, it should be reflected in our emulator. In the next module, we will start building our project and learn more about the basics of React Native.